In the previous video, as I told you that we will be measuring the height of the obstacle in the upcoming videos. So this is the video now for measuring the height of the obstacle. Okay. And once we have the height of the obstacle, then according to that height we will be performing a parkour action. So as you know that for now we have a raycast for detecting the obstacles. As you can see, when we come close to this obstacle, the ray turns red and it gives us information about that obstacle. Okay, so now what we want to do right here in order to measure the height of this obstacle is from the point where the raycast hits the obstacle. From that point in the upward direction we will be creating another ray, and then by using that ray we will measure the height of this crate, and then we will perform a parkour action. Okay, so let me tell you visually how we will do that. So consider this the crate. Okay, then when our ray detect that in front of the player is a crate, okay, then from this point, okay, this point we will create another ray in the upward direction, which will be our height ray, and then by using this height ray we will detect the height of this obstacle. Okay, so now open up the environment checker script, and right here at the top create a public float by the name of height ray length, and this will be equals to 6 by default. Okay, then just as we did for detecting the obstacle, okay, we created a struct in which we have the hit found pool and the raycast hit by the name of hit info, so that we can access these two anywhere. So in the same manner we will be creating a pool for our height. So we will say public pool, let's name this as height hit found, and then we will create a public raycast by the name of height info. Okay, then as I told you, when we detect a obstacle, after that we will be detecting the height of that obstacle. So we will say that if hit data dot hit found, it means that if we found any obstacle that is on the obstacle layer, okay, just as we did right here. Okay, so if we found any hit, then what we want to do, we want to set now the direction of our height ray length, or you can say the origin. So as I told you, the origin of the height ray will be from this point where the obstacle detection ray hits the obstacle. From this point in the upward direction we want to create the height ray. Okay, so for that we will say var, and let's name this as height origin, and this height origin will be equals to hit data dot hit info dot point. Okay, so this hit data dot hit info dot point is this point, and then from this point in the upward direction we want to create a ray. Okay, so let's set up that direction in the upward route. Okay, so we will say vector 3 dot up, okay, plus vector 3 dot up. So this will basically tell the ray to go in the upward direction, and then we want to limit that ray by some height. Okay, so for that, as you know that we have created this height ray length, so we will pass height ray length so that the ray doesn't go infinity in the upward direction. So now when we have the height origin, now let's actually create a raycast. So for creating a raycast we will say physics dot raycast. Okay, first of all it needs the position from where we want to create the raycast. So as you know that we have already set the position of the height raycast, which is stored inside this height origin. So we will pass this height origin, then we will say vector 3 dot down, because from this down position in the upward direction we want to go, so that's why we use vector 3 dot down. Okay, and then in the out we will store the information, so we will say hit data dot height info. Okay, and then as I told you, we will be limiting our ray by the height ray length, so we will pass now the height ray length, and then in the end we will pass the obstacle layer, because we only want to measure the height of the objects that are on the obstacle layer. Now after this we want to visualize this ray so that we understand it more perfectly. Okay, so as you can see that right here we visualize our reduction ray. So now we will be using that code for our height ray, but we need to do some changes right here. Instead of the ray origin, now we will pass the height origin, and then instead of the transform dot forward we will use the vector 3 dot down. Okay, and instead of the ray length we will pass the height ray length, and then right here instead of hit data dot hit found we will say hit data dot height hit found. Okay, and as you know that we don't have any code in order to make this height hit found true or false, so right here, just as we did for our obstacle detection ray, now we will do the same for our height ray. So we will say that if the hit data dot height hit found will be true if we found any obstacle that is on the obstacle layer. Okay, so if we found anything, then we will set this height hit found to true. Okay, so now if this hit data dot height hit found is true, then we want the color of this height rate to be blue, or else if we don't find any obstacle, then the color will be, let's just say, green. Okay, it is simple as that. Now we can simply save our code and get back to Unity. If we click on the player, we have the height ray length right there. Okay, so let's actually play the game, because we will see our height ray length right here now. So as you can see, for now we just have the obstacle deduction layer. So now if this obstacle deduction ray deduct any obstacle, and as you can see when we deduct, we now have a blue ray in the upward direction from where the obstacle deduction ray hits. As you can see, from this hit point in the upward direction we now have a height ray length, as you can see. Okay, just as I show you right here, when the obstacle deduction ray hits the obstacle, then from that point in the upward direction we will create a height ray length, and as you can see we have a height ray length. Okay, so now once we have this height ray length, now we will be able to perform parkour according to the obstacle heights. Okay, but we will do that in the next video.